Greetings and welcome to Using the TI-84 Plus. I'm your presenter, Lynn Mann. In this lesson, we'll be going over how to find all the keys that you'll need to work with exponential distribution function. In other distributions, we were able to use one of the built-in functions. So we would go to second, vars, and we'd find our distribution here, and we worked with binomial, Poisson, geometric. With exponential, we don't have a built-in function like this, but that's okay. The math is relatively simple in terms of what we need to do on the calculator to be able to figure it out. So here's what we are going to need to use. We are going to need the e to the x button, which is second ln. So it's right here in blue. That is our e to the x button. And if you're curious, e is an actual value. It is a number like pi. If you're curious as to what it is, you can go e to the x and then the exponent to be 1 and hit enter, and you'll see that it's approximately 2.7183. Now e goes on forever. This is just 4 of the decimal places for e. The other key that we're going to need, besides normal math stuff, is the ln key. So instead of hitting second ln, we'll also need the ln. We will use e to the x when we are looking for probability. When we are given the probability, we will need the ln key. Ln and e to the x are opposite functions of one another. Just like addition and subtraction are opposites of one another, multiplication and division are opposites of one another, these two functions are opposite of one another, e to the x and ln. So again, when we're looking for probability, I'll use the e to the x. When I am given probability and I need to find my x value, then I will use the ln key. Let's move on to an example of how we can use the TI-84 Plus to solve some exponential distribution problems. Let's say on average, a certain computer part lasts 10 years. The length of time the computer part lasts is exponentially distributed. So we're going to need some information to work with the exponential distribution function. 1, I'm going to need to know my x value. And 2, I'm going to have to know my lambda value. My lambda value is 1 over my average. In this situation, my average is 10 years. On average, a certain computer part lasts 10 years, so my average is 10 years. Lambda, therefore, is 1 over 10, in other words, 1/10. Now that we know our lambda, we can move on to working with problems. What is the probability that a computer part lasts more than 7 years? When we're working with more than 7 years, the equation we're going to use is e to the negative lambda x power. Because this is more than 7 years, my x value is 7, my lambda is 1/10, and therefore I can just start keying it in. Second, e to the x, parentheses, because this is all goes up into my exponent. It is a negative lambda, so I want to use the negative key, not the subtract. Negative 1/10 times my x value of 7, end parenthesis, and I hit enter. And the probability that my computer part will last more than 7 years is 0.4966. Let's find the probability that it will last less than 3 years. Well, when we work with less than a value in exponential, I need to first start off with 1 minus, and now I use my exponential function. Second, e to the x, my lambda has not changed, so negative 0.1 times the amount of my x, which is 3 this time. So the probability that the computer part will last less than 3 years is 0.2592. It's about 25% of the time the part won't last past 3 years. What if we have the probability between a couple of times, like What's the probability that your computer part will last between 9 and 11 years? Well, when we're in a particular region from 9 to 11, then here's what we can do. We can take the exponential function 1 minus our exponential function of the higher one minus 1 minus the probability or our lower boundary. But that's really big and lengthy, and it turns out that if you just do your exponential function of your lower one minus your upper one, you'll get the same answer. So if it is in between, I am just going to go second e to the x, my negative lambda times my lower boundary, okay? And then I want to subtract it from the upper boundary. So I did hit the key, the over key to get out of the exponent. I don't know if you saw me do that, but I did. Exponent second e to the x. My exponent is negative lambda times my upper boundary of 11. You'll see my little cursor is still up there in the exponent. If I want out of the exponent, I could just hit over and it gets out of that exponent. Okay. If you were in between two values, exponential function to the lower boundary minus exponential function to the higher boundary. So the probability that my part will last between 9 and 11 years is about 0.0737. What if I am told what percent or probability? 80% of the computer parts last how long? 80% of computer parts last at most how long? Well, this time I'm given the probability and I have to work backwards to find this x value. That means I have to use the ln. And the equation that I'm going to use is the ln of 1 minus the probability that I'm given, 80% in this case, so 0.80, divided by my negative lambda. And therefore, 16.0944, in other words, 80% of the parts will last at most about 16 years, 16.1 years. Okay, so just to recap, if you are looking for probability of a value greater than or more than, you will just use the exponential function of e to the negative lambda x. If you are looking for a value at most or less than a particular time frame, then you're going to have to use 1 minus the exponential function e to the negative lambda x. And when we have a range of values from a low value a to the high value b, probability that a is less than x is less than b, then we'll have e to the negative lambda a minus e to the negative lambda b. If you are given your probability, then what you'll do is you're going to use the formula of the ln of 1 minus your probability, all divided by negative lambda. All right, that's it for this time. Until next time, be seeing you.